Frederico Degrange, thanks so much for coming on to Evolution Soup all the way from Argentina, South America. You are a doctor of natural sciences and a researcher from CONICET, working at the Earth Science Research Center in Cordoba City, and your main interest is in the study of the extinct phorusrhacids, also known as the terror birds, specializing in those species that once roamed your native Argentina. Well, people know you as Dino. And so before we dive into the amazing world of the terror birds, I just want to ask you, Dino, how are you doing? And have you been able to get back out into the field?
Hi, Mark. Thanks for inviting me to participate in your YouTube channel. Glad to share with all you people about these amazing birds, the terror birds. To be honest with your question, it was kind of hard actually, because Argentina had the longest lockdown. So we have to basically do home office, being away from collections, fossils, extant specimens. And that implies that also field works were canceled, or at least delayed. Luckily for me, I will be in the field in 2 weeks from now, after 3 years of not going. So I'm really excited about it. Hopefully we will find more terror birds there. But yeah, it was hard. It was really hard being away from fieldworks, from collections, from fossil specimens, from colleagues, communication through with our colleagues, with the people here, with all the paleontologists that work here in the SICTERRA, the institute where I work, was hard.
Dino, did you always have an interest in science, and in particular, the extinct animals of South America?
Yes. I was always passionate on paleontology. I like to tell how I actually got interested in this. When I was 3 years and a half, my grandma, Gladys, gave me one of those really basic books for kids, you know, those that have like 8 pages with, I don't know, 4 or 5 dinosaurs, saying something like Tyrannosaurus was the largest dinosaur carnivore of the world. Diplodocus were as long as 2 buses, something like that. And I still remember the images of that book, because that book actually marked my life. And I, at that point, being really young, I said that, oh, I want to do this, I want to study this, I want to see, well, obviously at that time, I want to see a living dinosaur. Luckily for us, I can see them all days here when I see a bird. But based on that passion that I still have, I start studying paleontology. Actually, it's a BS in biology with orientation in paleontology in La Plata City, in the Universidad Nacional de La Plata, in the Natural Science University. When I started the career, to study the career, sorry, I get interested in the origin of birds. So like late theropods and the transitions to birds. But that's a field that it's not very well developed and studied here in Argentina. And when I was in the second year of my career, I knew a colleague called Dr. Claudia Tambusi, who lately was my PhD advisor. And when the time comes to start working on this, when I got my degree and start thinking about a PhD, I actually was interested in studying Mesozoic birds. But Claudia told me, look, that's not my specialty. I work with Cenozoic birds, but I have this group of amazing birds that we can do a lot of things with them. and she started talking to me about phorusrhacids or terror birds, and was love at first sight. I even have a tattoo of a terror bird. After that, I decided that I wanted to dedicate my career mainly to study the paleobiology, how they live, how these animals live, how they hunt, how they run, if they were capable of flying. These animals are amazing, and luckily for me, there are still a lot of questions. There were a lot of questions at the moment, but there are still a lot of questions that need to be answered, and that's my main motor to study and work with them.
Well, most people will be aware of the giant flightless birds that hunted the open savannas of ancient South America, but since most of what they've heard is from movies and documentaries, the real facts are largely unknown. So let's just start with an overview of the phorusrhacids. When did they live, and what did they look like?
I usually say that imagine like a rhea or an ostrich, but with a larger head, like much larger head, like this large head. and basically a terror bird, a phorusrhacid, actually, as we call it here in South America, it's a group of flightless birds, at least most of the species, with highly running abilities, reduced forelimbs, really narrow pelvis and body shape. But the main feature, of this group is the head. And especially the beak. They have a really long, narrow, and tall beaks, endowed with a distal hook at the tip of the beak. And differently to the rest of the neornites, that is the modern birds, terror birds are not capable of moving the beak regarding the neurocranium, a feature that it's called cranial kinesis. Most neornites, as you can see, this is a seriema. This is the most close relate bird to terror birds.
They're alive today, aren't they?
They are live today. They are extant species. There are two extant species, the black-legged seriema and the red-legged seriema. They can move the beak in relation to the neurocranium. Phorusrhacids lost this hinge and the palatal hinge, and that makes the skull much more rigid, which is related to the hunting technique that they had. Terror birds live. They are registered from the Eocene, 52 million years ago, to the late Pleistocene. That it's about the latest record. The youngest record is it's about 17,000 years, and they live in South America mainly, and in North America we have one species, but there are also some questionable remains in Africa and Europe that probably, and I'm quite sure actually that they are not terror birds. They are probably another group of cariamiforms, the group that includes terror birds.
Related,
yeah. They probably they are a different group of cariamiforms related to terror birds, but not terror birds. Terror birds were carnivorous birds. They were predator. They hunt. They chase the prey running and hunt them down with using the beaks. And what we don't know exactly what kind of exactly what species they predate on, but we are quite sure that we basically ate mammals. There were different group of mammals really diversified here in South America during the time where terror birds were the apex predators here. So also the terror birds showed a high diversity of body sizes. They were like, the smallest theropods were about 90 centimeters tall and about 5 kilograms, while the tallest ones were around 2.5 meters, 3 meters tall, and around 150 kilograms. So probably there were we also know that there were different sizes of theropods living together in different areas here, especially here in Argentina. So we know that we are quite sure that probably there were a division of the niche based on body sizes. That means that smaller theropods probably predate on smaller prey like rodents or rodent-sized mammals. And while larger theropods probably predate on much larger mammals, ungulate size.
So those paintings, the paleo art that we see of them attacking small horses, I mean, is that something that actually happened, or?
Yes, probably yes. Not using the feet.
Well, you've done extensive studies on the massive beaks of the various terrorbird species. So what can you tell us about them? What was unique about these beaks, and what could they do?
Well, terrorbirds have, as I commented previously, they have like large, narrow, long, tall beaks. It's a feature that most terrorbirds have. You can see how narrow they are. Wow. This happens in all species of terrorbirds. These are real sizes terrorbirds, and this is the hook that I commented, that I told, and these are the nares here, really small, related to the skull size. And what we know about this, there are two things that are really peculiar about the morphology of the beak. One is that the beak is hollow, fully hollow, but the walls of the beak are actually quite thick. And the other thing about the beak is the functioning of this skull. The skull is rigid, basically because they lost these bending areas here in the palate area, and they lost what is called the craniofacial hinge, which is in a seriema is this area here. You can see that it's a thin area. The same happens with the palatal areas here in the seriemas. They are thin areas that can bend when jaw muscle contract. But in the case of these guys, actually that didn't happen. With the jaw muscle contract, basically they were just to close the beak, and that's it. To raise the jaw up. So it's basically jaw muscles work as closing jaws, but not rising down the beak, which is something that happens in most neorniths now. Terrorbirds, and this is an exclusive feature, are the only truly akinetic neorniths. And this is important because probably this was the key feature that allowed diversification of this group and the specialization in the carnivory, in the way that they chase and kill the prey. As I said, terrorbirds chase prey through running, but when they were close to the prey, they needed to hunt them down, and to do that, they basically use this axe-like beak doing this.
Ouch.
And yes, no, shouldn't be pleasure.
Not nice.
Not nice. And that way they hunt them down, the prey, and once they have them in the ground, they probably step on it and tear apart the prey using these beaks. We know also that jaw muscle of terrorbirds were more suited for strong bite than fast bite. So we know that once the prey was down, they were capable of hard biting this animal to tear them apart.
And could it be, Dino, that originally their ancestors had the hinge, and because of their preferred way of attacking, they lost the hinge? Or did they never have the hinge?
As far as we know, the latest records of terror birds, at least of skull records, we know that they lost the palatal hinges. But there are some terror birds, another group of terror birds that actually retain the craniofacial hinge, but they have these areas totally rigid. So still, even if they having the craniofacial hinge in the smaller species, skull was still rigid because the palatal area couldn't move. So we are still trying to figure it out how this evolution were. As far as we know now, larger terror birds were probably have more rigid skulls than smaller one, but all terror birds have rigid skulls. So other thing that we are looking for is the neck muscle and how they work, because as far as we know, they show strong ventral muscles which allow them to do this movement, but they have like really strong also ligaments that allow to recover the neck position without using much energy, which fits perfectly in our hypothesis of these animals doing this kind of movements to chase the prey.
Well, the other impressive feature of these birds is its powerful legs. Dino, how fast could they run, and what else could these muscular limbs do?
Terror birds were actually quite fast. They were as fast as an ostrich. An ostrich can run 40-45 kilometers an hour, and terror birds probably run at the same velocity or even higher. We know this based on the tarso-metatarsus structure, the morphology of the distal portion of the hind limb. Hind limbs in terror birds were quite slender, the bones, I mean, but the muscles, especially the muscles that flexion the hind limb, were actually quite developed. And that it's important because they allow them to make fast and strong movements of the hind limb to stroke against the floor. When you are a runner, you need those kind of strong and fast strokes against the floor, because that gives you more velocity and based on the reaction forces that you cause. So the hind limbs, as far as we know, they are very, very well suited for running, for chasing the prey through running. There are some hypotheses that said that states that probably they use the tarso-metatarsus and the feet for chasing down glyptodons, for example, breaking the carapace that they have. Nevertheless, that it's highly unlikely based on two premises. One is that the carapace is actually really, really strong. Of the glyptodon would be really difficult to break it.
I think we saw that in Walking with Beasts, didn't we? Something just like that.
Yes, something like that. And the other problem is that actually the assumptions used for that calculation, have some errors that actually increase the value of the strength of the tarso-metatarsus. So I wouldn't say that they were capable of breaking carapaces of a medium or large size glyptodon. probably something more like a mulita size. I mean, something like that. Probably could be crushed on a large by a large terror bird, but not by the smallest one.
One feature that we can't help but notice are the tiny wings that these creatures have, rendering them flightless. So what's the story of these reduced forelimbs? Did these birds ever have the power of flight? And if so, why did that ability disappear?
Most species of terror birds have really reduced forelimbs. Really reduced. But the smallest terror birds, the coelopterines, probably were capable of performing really clumsy flights, really short distances, like seriemas do now. Even seriemas prefer to walk, to run. Probably flying was not the preferred locomotion style of these smaller terror birds, and probably the flight was even much more clumsy than the one observed in seriemas. This trend to have reduced forelimbs is observed in other cariamiforms. Cariamiforms is the large order of neornithes that include seriemas, terror birds, and different groups of birds. Most of them really diversified in Europe, but curiously, being a really large order in the past, they are represented now by only two species, the two seriemas. Nevertheless, in all those cariamiforms, we see a trend to terrestriality. We see elongation of the hind limbs, a strength of these hind limbs, and also we can see the trend to the reduction of forelimbs. Although most of these Europe cariamiforms were probably they were capable of perform flight, at least as seriemas, but they show also this trend to the reduction of a forelimb. That it's actually a trend observed in when you see the whole picture of cariamiforms. The trend to the reduced forelimb and the trend to the elongation of the hind limb and the postacetabular area of the pelvis, where these muscles that I told you before, that I talked to you about before, are originated. Unfortunately, we don't have very well documentation about how the skull was in most of these early cariamiforms.
Well, as with many of these fascinating animals known today as the prehistoric megafauna, they ruled for many millions of years only to go extinct. So what do we know about why the terror birds disappeared from the planet?
We are still trying to figure out what happened with terror birds. The most plausible hypothesis is that they got extinct because terror birds got very specialized in the prey that they chase, they eat, they hunt. And by the time of the Great American Biotic Interchange, most mammals, native ungulates of South America, were declining, also based on landscape changing. And the reduction on the prey caused a reduction on the hunter, on the predator. These probably were more accentuated when for example, the ungulates like horses, cervids, came from North America to South America, and they were better were more suited to get better the natural resources here. That probably caused the accelerated extinction of most native ungulates. With that, with the fact also that these ungulates that came from North America were also really good runners, well suited for velocity and for high velocity, which were also more implies that they were also more difficult to be chased. Probably were one of, at least is at the moment, it's the most plausible hypothesis of why terror got extinct.
So you're saying ungulates like those horses that we mentioned before?
Yes,
that
yes,
kind of
yes.
thing, and they were almost able. It seems amazing that they could outrun a terror bird, but you're saying that perhaps they did.
Probably they did. Terror birds also they participate in this Great American Biotic Interchange. Although most species are registered here in South America, in Argentina, Uruguay, and Brazil, there is one species, Titanis walleri, registered in Florida and Texas, in the United States, which is a really large terror bird.
Oh, yeah.
But it's the only one.
Dino, people will want to know if these animals crossed paths with early humans. So did humans and terror birds coincide in time? And if so, who hunted who?
Well, we know that youngest records of terror birds here in South America are about 17,000 years. That it's basically yesterday in paleontological times. But although oldest records of human activity, at least here in South America, are around 18, 19,000 years, for example, in Chile, and 14,000 years here in Buenos Aires province in Argentina, here in Argentina. So basically, terror birds share time with humans, but we haven't found any record of being in the same place at the same time, only same time. This is important because, as far as we know, humans didn't have anything to do with the extinction of terror birds. Most likely, the terror birds, these youngest terror birds, registered in Uruguay, were smaller size, probably more generalist, well suited for not as specialized as the common idea of what a terror bird is, meaning this guy, for example. So humans didn't cause the extinction of terror birds. They coexisted, but in different areas. Terror birds' youngest records are from 17,000. Oldest records in South America are about 18,000. And we have also records, the oldest records in Argentina are about 14,000. So there is a coexisting in time, but we haven't found evidence of activity or fossil remains together of terror birds and humans.
Well, I'm sure we could talk all day about these fascinating animals, and I'm sure you and your team will continue to uncover exciting new data about the Phorusrhacids for the world to see. So, what about your latest finds, Dino? Is there any fresh new data that you can give us an exclusive on?
I am actually trying to concentrate my analysis basically on two lines. I work with finite element analysis and engineering technique that allow us to know how the stress distributes on the skull. And we have made some analysis on this guy using jaw muscles, and in this guy called Shashawabis. These are the two skull morphotypes. You can see that there are some differences in them. Yeah. And based on those analyses, we know that skull functioning were quite similar among terror birds. That is important because tell us that hunting techniques were basically the same in all terror birds. But to chase something, you have to see it, hear it, look for it. So we are also studying the brain of the terror birds using computed tomographies. We have made 3D models of the brains of terror birds. We know that terror birds have also really developed structures to process vision inputs. That it's important because you have to see something that it's far and be able to calculate if you will be able to chase it. We know that terror birds were they were suited for process visual information. They have probably very well developed vestibulo-oculomotor reflexes. That is something that it's important when you are chasing something, because if the prey moves, you have to keep the gaze on what you are chasing. And we are also studying visual fields to see what they can perceive, because something that may call the attention is that when you are a terror bird and you have something like this, basically the beak is covering your face, your eyes. And we know that terror birds actually were very good looking at the tip of the bill, which is obviously really important when you are next to the prey and you have to hunt them down.
I'll leave links to your social media and research papers in the description below. And all that's left to say is thank you very much indeed, Dino, for coming on to Evolution Soup.
Again, Mark, thank to you for inviting me, and thank you to all for hearing. Hopefully you will find these animals as fascinating as I did. And obviously I'm open to anyone who wants to contact me and know more about this incredible animal.